Hello everyone, my name is Hubert and welcome to Teach Me channel. Today we'll be looking at GCSE Physics density of materials. Now, so the question of the day today is, what's heavier, 1 kilogram of feathers or 1 kilogram bar of lead? So as you probably know, the answer to that question is that they are both the same weight because they both weigh 1 kilogram. The only difference is how much space each will take up. 1 kilogram bar of lead will actually be pretty small, whereas 1 kilogram of feather would be probably held in a massive bag. So this is what density is. This is where density comes in. Density of materials is the relationship between the weight of an object, the mass of an object, and the space it takes up. Because density measures how compact an object is, how tightly the particles that form the object are packed. So if we have an object that has tightly packed particles, that object can be said to have high density. If we have an object where the particles are not very tightly packed, this object has low density. For example, let's have a look at the different states of matter, so solids, liquids, and gases. In solids, we have tightly packed particles that are bound by strong forces, and they cannot move much at all, and they're positioned right next to each other. They're all very tightly packed. So a solid form of an object solid form of an element or molecule, solid form of a molecule will usually have high density. Liquids, on the other hand, molecules have a bit more energy in liquids and they can move around a bit more, which means they are not as tightly packed. They still can't go off everywhere, but they can move around a bit more. They are afforded a bit more mobility, which means they're a bit further away from each other, therefore they're not as tightly packed. Therefore, most liquids will have lower density than solids. Whereas gases have a lot of energy, which means that these molecules can move very fast. They can move apart from each other, quite far apart from each other. So the particle in gases are least compact. Therefore, we can say that gases have lower density than liquids and solids. So that's a general rule. Now, of course, there are exceptions. For example, water is one of them, where solid is actually less dense than a liquid in most cases. So there are some exceptions, but general rule of the thumb is that solids are the most dense and gases are the least dense. So, going with that concept, what is density? How can we define density mathematically? Density is mass in kilograms divided by volume in meters cubed. So, again, this goes back to our definition, how compact something is. Basically, we have mass of an object divided by the volume of an object. And density is measured in kilograms per meter cubed. So again, this kind of makes sense, doesn't it? How compact an object is, how tightly packed the particles are. Because, say, if something has high mass and very low volume, aka the bar of lead, we will get a high value here for density. Otherwise, if we say have low mass and that object takes up a lot of space, that means it cannot be very compact. So we will get a low density. For example, the feathers we were talking about earlier on today. So this is the main equation you guys need to know when it comes to density. Of course, if you, in an exam question, if you say get a question about a mass, to find out a mass whilst you know density and volume, you can rearrange this equation algebraically to get that mass. So, moving on with that, now how would we measure this density, guys? We know what it is, we have some examples, we know how the density kind of behaves. Now, how do we measure density? You get given a solid object, how would you measure a density of that? So here I drew up a quick diagram that outlines how to measure density of a solid object. So first of all, we need to find out the mass. We need mass and volume to find density. So first of all, we need to find out the mass of the solid object by weighing it. That's the easiest way. Just plop that object on a weighing scale, and that will give you the mass of the object. Now, we need to find out the volume, which is the second constituent in what becomes density. So how would we find a volume of a solid object? Now, if this object is regular shaped, for example, it's a cylinder or it's a cube or something like that, or even a pyramid, something that can be mathematically calculated, some shape where we can mathematically calculate the volume fairly easily, then we can just calculate the volume mathematically. We can just measure up that shape and calculate the volume. Now, what if you just get given a pebble, some pebble which has irregular shape, and you cannot easily calculate it mathematically without jumping into this big mathematical rabbit hole? Then we have to use something called Eureka can, which I drew here. Eureka can is filled with water up to the nozzle, and in its natural state that water does not flow out of the Eureka can. However, if we plop down the object, any object, then what this object will do is it will displace the water. It will displace the water, and therefore the water will be pushed up through the nozzle into the measuring cylinder. And therefore, since we are putting that excess water into the measuring cylinder, we can see exactly how much water has been displaced. And as physics go, the amount of the volume of water displaced is equal to the volume of the object. So whatever volume of water we get in that cylinder, that's the volume of our object. So now, knowing the mass of the solid from weigh scale and the volume of a solid from either calculating it in a regular shape or measuring it in Eureka can, now we can plop this down, plug these values into the equation, and we get density of the said object. Now, what about liquids? What if you get given some, say, cooking oil, and you need to describe the density of that cooking oil? Well, what we need to do in liquid oils is, again, same concept, same core concept, guys. Mass divided by volume. So we need mass and we need volume of the liquid. So first things first, we would put empty measuring cylinder on a weighing scale to have the mass of the measuring cylinder to zero the weighing scale. So any other mass that we get will be purely from the cooking oil as opposed to the measuring cylinder itself. So first of all, we do that. Then we can put some cooking oil in. We would put a described predetermined volume as marked on a measuring cylinder. So for example, we could put in 10 ml of cooking oil, and because we're putting exactly 10 ml using measuring cylinder, that will give us the mass of that liquid. And technically, we could get density from that. We could plug those values in, the volume that we get here from the measuring cylinder and the mass that we get from a weighing scale, and technically we could get the density value. But this method often can be a bit inaccurate, where sometimes if the liquid's viscous, some of it will remain on the wall, and therefore you will actually have a bit more in the measuring cylinder than you think you do, because not everything pools down at the bottom. So there are some inaccuracies happening. So a way to try to combat that is to pour another 10 ml on top of that. And now we have a volume of 20 ml and new mass, and determine density from that. Pour another 10 ml. Now you have a new volume again, new mass, determine density of that, and keep going until you have a full measuring cylinder. And then you have all these different values for density, and you just simply take the average value for density, which will probably be the best answer for this question. So that's how you measure the density of liquid objects. That's how you would do it. Sometimes you will get an exam question where they will ask you to design such an experiment to find out the density of a solid or a liquid. So that's why I included this here. So hopefully now you guys should know how to do this. And this is it for today. Thank you very much for watching my videos. I really appreciate this. If you want to stay up to date with some more videos like this on GCSE Maths, GCSE Biology, Chemistry and Physics, and some A-level corresponding A-level sciences, and some biomedical sciences, hit that subscribe button below. If you think this video helped you, give me a big thumbs up. Thank you again very much for watching, and see you next time.